Google gets a bad rap, and I don't know why. You see, over the past 2 weeks, while everyone was talking about DeepSeek and OpenAI o3, Google announced that their latest, most cutting-edge Gemini models are now available for everyone, both in their consumer application and for developers using the API. And I say that Google gets a bad rap because these models are so good, yet they get a fraction of the interest and attention. And that's really unfair in my opinion because the Gemini models are one of the most developer-friendly models out there. So what makes the Gemini 2.0 models really good for developers? Number one, insanely long context windows, which means that the information you can feed in these models in one go is preposterously large, which, as you'll see today, makes retrieval augmented generation relevant for a lot of document processing tasks. For example, the Gemini 2.0 Pro model has a 2 million input context length window, which means that it can take in a document that is 30% larger than all of the Harry Potter books put together. Number two, these models are multimodal. They can take in as input audio, text, images, video, and soon they'll be able to have multimodal output as well. Number three, they have reasoning capabilities, and moreover, they have many utility tools that are built into the API, like the ability to do Google search or execute code. And all of this is in a pretty cost-effective package and a pretty generous free tier and low response latency. So all in all, I'm not sure why Google does not get the hype it deserves. In many ways, you have a lot of vibes-based evaluations of LLMs and their providers, and even though Google literally invented the transformer and ushered in the AI revolution that we're living through today, it seems like Google is still in that process of having that breakthrough moment where the Gemini models become part of public consciousness. So what we're going to be doing today is put Gemini 2.0 Pro to the test. And what we're going to do is, number one, go through all of its multimodal capabilities and test out its different functionalities. And number two, build an end-to-end multimodal application that takes as input YouTube URLs and returns chapter notes and descriptions, as well as a system that takes a PDF as input and returns a YouTube script based on the content of that PDF. My hope for this video is to give you some intuition on how to work with the Gemini API and how it can change your approach to using LLMs with different types of input data. As I also mentioned earlier in the video, I think the long context window that the Gemini models provide will truly revolutionize how we approach document processing with LLMs and may render retrieval augmented generation irrelevant. Before we get started, this video is brought to you by Datacamp. Datacamp is a data and AI skills transformation platform that allows you or your team to transform your data and AI skills wherever you want, whenever you want. Whether it's interactive courses on topics like LangChain, Hugging Face, the OpenAI API, retrieval augmented generation, or more, tracks designed to help you or your team pass key technology certifications, or avenues to go beyond learning, like unguided projects, Datacamp Data Lab, and more. You can start for free by following the link in the description. And with that said, let's get started. All right, so I have this notebook here that we're going to be using today, which is essentially where we're going to be using the Gemini 2.0 model and the Gemini API and building our application at the end with Gradio. So all of the solution notebook plus the walkthrough code notebook will be uploaded on the YouTube description link, so make sure to check it out below. First off, we're going to install some required packages here. As you can see, I've already installed them just for the sake of time, but the packages that we would need to install are one, the Google Generative AI package, which is the official API of Google for interacting with Gemini. We're going to download Gradio, which is a low-code framework for building interactive web apps, specifically for machine learning and Gen AI use cases. We're going to download the YTDLP package, which is a tool for downloading YouTube videos, as well as the wget package, which is a utility for retrieving files from the web. So all you need to do is run this cell here at the beginning. As you can see, I will get a lot of requirements already satisfied, messages, which essentially tell me that all of these packages are already downloaded. Now, the next thing that we're going to do, of course, is we're going to import all of our packages. So we need to import the necessary libraries here, and what we're going to import are from any Gemini related packages. We're gonna import from Google, import Gen AI. This will allow us to work with the Gemini model, and then from Google.Gen AI, import types. This is especially useful when working with multimodal inputs, and we're gonna see how. Don't worry about it. Then helper packages that we're going to import. We're going to import time to time some operations. Specifically, you'll see when we're downloading videos, you want to give the make sure that we're checking every 10 seconds if the video is downloaded. We're going to import OS because we're going to check some files at some point. We're going to import pill.image, which is used for handling image data. IPython display to display some markdown HTML images that we're going to have. This is a Google Colab package just to be able to manage user authentication for the API. I'll walk you through how to get the API and how to put it on the Google Colab user data. We're going to import pathlib because we're going to manage some file directories, and then Gradio to do the web interface. As I mentioned, the YTDLP package, which lets us download YouTube videos, as well as the wget, which lets us download files from the internet. So I'm going to run this here, and then we're going to be good to go. I'm also going to check whether we have all of our files here. So as I mentioned, we're going to be using multimodal capabilities. So I have all of these files here uploaded already. I'll walk you through how to upload them shortly. All you need to do is press on upload to upload your files, right? That said, they won't be available once you open this in Colab immediately. So we'll make sure to link them in a data lab where you'll be able to download the files as well. And with that, we can actually get started. So first things that we need to do is get access to the Gemini API. And to get access to the Gemini API, it's actually quite easy, as well as, as I mentioned, there's a generous free tier that we're going to be using today. So you don't need to necessarily worry about costs, especially if you're experimenting like this. All you need to do is go to the Google AI Studio and then sign in with your account. So once you arrive at Google AI Studio, you'll see this type of interface. Essentially, all what you need to do to get your API key is on the top left-hand side, get API key. Once you're here, press on this button. So I already created my API key, but all you need to do is create an API key, name your project, and then all you need to do is press on this button here that says API key, and you'll be able to copy the API key. Now, once you've copied it, all you need to go back is set up the API key in your notebook. So Google Colab does allow you to store environment variables. So all we need to do is press on this secrets here, this key icon. As you can see, I've already added my API key and I named it Google Gemini API. And make sure that it has notebook access. So all we need to do is add a new secret, add your API key, name it, and then make sure to name it Google Gemini API key, just so you don't have to change the code. And that's about it. If you're using this locally, you can store the variable in a .env file, and that's it. Now, something that's quite important as well to understand is that the Gemini ecosystem has a lot of different models. So probably the most useful for production use cases, I would say, is the Gemini 2.0 Flash or the Flashlight Preview, because these ones are pretty fast, pretty intelligent, they're multimodal. But we're going to be using the Experimental Pro model today. Because essentially it just has one of the highest kind of accuracy scores that they've had, and it would be interesting to see. Now, important to know that these are experimental models. They're not yet deemed ready for production by Google, but you can use them, right? So that's just one thing to keep in mind. And then with that said, yeah, we can get started. And what we're going to do is we're going to run our first prompt. And then in order to run our first prompt, we're going to use the generate content stream function, right, which is from the Gemini API. And what this does is that it lets you generate responses for a given prompt in a streaming fashion, right? So streaming means that as it's creating the output is rendering on your screen, and then you can do non-streaming, so generate content, right? This is waits until the full response is generated before this playing it. And I'll walk you through the function and what type of parameters it takes, but it only takes essentially two parameters. What is the model, and then what are the contents, right? So here the API, the prompt, whether you're adding files, so on and so forth. But we'll be able to walk you through it shortly. So first things first, I'm going to define my model because I'm going to be using this model ID a lot. So instead of each time writing Gemini 2.0 Pro X blah, blah, I'm just going to write model ID equals the model name, which is Gemini 2.0 Pro Experimental 0205, short name. And then if you want this for production ready use cases, or you want to run faster inference, just switch this for Gemini 2.0 Flash. Now, next thing we're going to do is retrieve our API key. So as I mentioned, we're going to use the function provided by Google Colab here. So we're going to do user data get Google Gemini API key. That's the name of my API key that I named it here. Then we're going to initialize a client, right, with the Gemini API. So client equals GenAI dot client API key equals the API key. And again, the GenAI package comes from here, comes from Google. And now we're ready to start creating some responses. So what I'm going to do is first I'm going to test off here. I'm going to create a response variable, which is where I'm storing the output prompt, right? And as you can see, the auto complete is working pretty correctly. So client of models, right? Generate content stream. And then we're going to do model equals model ID, as you can see above. And then the contents. Now, given I can set this in a list, or I can set this on a prompt on its own. Given that I'm not adding any other file or input to the contents, I'm just going to put a string here, and I'm going to ask it, explain to me how the stock market works, right? And then what we're going to do is we're going to iterate over each streamed response, right? And I'm going to do for chunk and response, print chunk text, and we're going to end it with a backwards, right? And what this does is like it just prints the text output without any extra line breaks, right? And essentially what you're seeing here is that for each chunk in the response variable, I'm printing out the text, right? And then we're not ending this with a break line, we're ending this with nothing, right? So we avoid breaking line. So I'm going to generate my response. The API key is here. Okay, let's break down the stock market. It can seem complex, but the core concepts are relatively straightforward. The very basic idea, ownership shares, so on and so forth, how stock prices are determined, supply and demand, blah, 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 blah. This is how the stock market runs. If there are any finance experts on the video today and you see anything that is wrong, let us know in the comments. We'd love to learn where Gemini is making mistakes. So that is essentially running over, kind of generating a basic prompt with the Gemini 2.0 API. But what's nice about using an API, instead of using something like Hugging Face or something along those lines, is that you also get a lot of helper functions here provided by Google. So input token length is really important consideration when it comes to price, but also the type of application that you're creating. If you feed Gemini 2.0 Pro a document that is like 2.5 million tokens, you want to know that, right? So I'm going to be going through a few helper functions. The first one is counting tokens, right? So here what this does is that it counts how many tokens there are in your prompt. And this is the function client.models.count underscore tokens. Again, really important for production use cases. I can easily see a unit test, for example, of like counting the input tokens to see if it goes beyond a certain limit so that you can do chunking or retrieval augmented generation, so on and so forth, right? So with that said, I'm going to create a new response. And then here, again, the autocorrect is pretty good. Count tokens. Usually I would use the autocorrect for this, but I'm trying to be pedagogical and go through line by line. So here what I'm doing is I'm putting in the model ID, and then the contents is what's the highest mountain in Africa. Okay, and then what I'm going to do is I'm going to print the response, and then we can take it from there. Again, here we're not printing out a response where the output is created, but we're just counting the tokens. So the tokens, we have around 10 tokens in this particular sentence. Now, one thing as well is that you can modify the model behavior, make it a bit less predictable, make it more random, adjust the type of response diversity using these parameters here, top P and top K. set a limit on the output token length, right? And then add any stop sequences to prevent certain words. So we can do this using, we looked at the generate content stream, right? Here we're using generate content. So again, similar functions. The difference is one is in streaming, one is in just outputting the content in batch. And then what you can see here is by using the config variable, and then we use the types function module that we imported from the Gen AI package, right? We use the function generate content config, and here we can set up a lot of different parameters. So for example, temperature controls randomness. The lower the value, the more deterministic it is, right? Top P, which is essentially that the combined probabilities of the words put together reaches a certain threshold. So here it's set to 0.95, so 95%, right? Top K equals 20, for example. I've said this is, when the model is creating the next word, it limits the keyword, the selection of the next word to the top 20 most probable words that you can create. Candidate count equals 1. How many responses you want to create? It can create multiple variations. I'm setting a seed, for example, to ensure reproducibility. Max output tokens equals 100. So this limits the response length to 100 tokens, right? What are the stop sequences? Presence penalty. So this encourages or discourages new topics. So higher value penalize repetition. And then frequency penalty, again, reduces repetition the higher it is. So with that said, what we can do is generate a response with the updated output parameters, right? So I'm gonna use here client models.generate content, right? Oops. And then my model is my model ID. Contents here is tell me how the internet works. But pretend I'm a puppy who only understands squeaky toys. And then for the config, I'm setting, okay, I'm gonna auto-generate this just for convenience. So types dot generate content config, right? Temperature, I'm gonna set it to 0.4, top P 95, top K 20. Now candidate count, I'm gonna set this to 1. I just want one variation. I'm setting my seed to 5. I'm setting my max output token. It seems like it's reading the example from above. Tokens equals 100. Correct. Stop sequences. I'm gonna set this to stop here. Presence penalty equals 0. Frequency penalty equals 0 as well, right? And I'm gonna so here close this here and then close this here, right? And then what I'm gonna do is I'm gonna put and mark down my response text. So with that said, okay, great output. Okay, little puppy, imagine lots of squeaky toys. Squeak, squeak. You have a squeaky toy, your phone or computer, and then it's, the output token stops at 100, right? So for example, if I made this 200, the response would be longer. Now, additional thing here that you can update or modulate with the Gemini API is adjusting safety filters, right? This does not mean that your model will become, if you remove the filters, it will become like the worst person on the internet. But it can slightly modulate down the type of safety filter you want to create, especially if you want to create, fictional content like deemed dangerous or violent, for example, right? And I'm going to use an exact use case here. And the way you can do it is by using, again, the types module and then update safety settings, right? So there are different thresholds that you can use. So block none, block only high, block medium and above, block low and above, right? So block none, you block none of the unsafe content, right? Block only content that is deemed high probability, medium and above, low and above. So here, you block most, you block some, you block few, you block none. And the different categories that they can define are, harm category: harassment, hate speech, sexually explicit speech, dangerous content, civic integrity. And again, it's not like if you do block none, suddenly all of the filters are off. There are kind of some pre-built filters into the models, even when you're blocking none. But for fictional content creation, for example, I think for especially stuff like danger content, we're going to be using it. So what I'm going to do here is I'm going to actually remove the dangerous content filter and then try to see what Batman would do without a safety filter on. So again, safety settings equals, I'm going to create my list here, types, safety setting. Okay, this function here. So yeah, category equals harm category dangerous content, agreed, and threshold equals block none. So yeah, category equals harm category dangerous content, and my threshold is block none. So I'm blocking none of the content that can be deemed dangerous or violent here, right? And then I'm going to ask my model to create a response, but first I'm going to create a prompt. So the prompt is here. I'm going to put this in this for ease of readability. So what are 5 punishment tactics that Batman can apply to the Joker after the Joker did serious harm to Gotham? List the tactics and bullet points, and they should range from least violent to most violent. The last one should be very vengeful. I'm going to pretend I'm a screenwriter on DC Comics here and then see what happens. And then I'm going to generate a response. So response is client models generate content, right? So my model equals my model ID. My contents is my prompt. Now, if I look at my config, I'm going to set my settings here. So types, generate content config. Wow. Google Colab is reading my mind. And then what I'm going to do, I'm going to set my safety settings equals to my safety settings that I've done here, right? And then again, I'm going to put my end markdown, my text response. So let's see what happens. I've removed the dangerous content. My threshold is block none. And then my prompt is a DC Universe inspired prompt on Batman getting revenge. And then we'll take it from here. Okay, where did I go wrong here? Now I see. I put réponse, not response. Okay, this will change now. Okay, so we'll see what are these punishment tactics. Okay, so here are 5 punishment tactics Batman can employ against a Joker after a particularly heinous act in Gotham, ranging from the least to most violent, and keeping in mind Batman's core, but sometimes strained no-kill rule. So, as you can see, still following the rules, it's not going off the rails. Least violent, Arkham Asylum, solitary confinement, and psychological warfare. Moderate, legal and systemic ruin. Increased violence, strategic incapacitation and imprisonment, right? Inescapable prison. The prison is a deep dark hole in the ground where it's nearly impossible for the Joker to escape. Damn. Severe targeted physical intimidation and controlled injury. This is where Batman operates in a very gray area, pushing his code to its absolute limit. He might engage in a brutal one-sided fight, carefully inflicting non-lethal but incredibly painful injuries. Damn. And then most violent, the Phantom Zone Exile. Still, still within the core values of Batman, but it does go a bit violent. So yeah, going back here, if you remove the safety filters, it's not gonna luckily it's not gonna become the worst person on the internet, but it will be able to go beyond what you've said. So fairly certain if I say this to block low and above, you won't get these types of responses. Now, one thing as well that you are able to do with the Gemini API is actually do a conversational experience where you're able to also interact with the model over multi-chats, right? And that's a pretty nice ability for the model to in creating kind of agentic or chatbot-like use cases. So with that said, first thing I'm going to do is I'm going to define system instructions, and I'm going to be using the clients.chat.create function. So my system instruction is you are an expert data scientist that can create effective code in Python. So here I'm just giving it some context over who it is and the type of kind of persona it should emulate. It's just some prompt engineering. And then I'm going to create a chat object here. So chat equals, again, client.chats.create. Again, all is correct here by the autocorrect. And then what I'm going to do is model equals model ID. Right, and then my config, I'm gonna do types.generate. Right, I'm gonna set my system instruction here. Right, and then so I created a chat client, right, and then I just gave it the system instruction, right, and then what I'm gonna do is I'm gonna create a new response variable. I'm gonna start chatting with this chat that I created given the system instruction, and I'm gonna use chat, right, dot send underscore message, right, and then the prompt that I'm gonna use, write a Python function that cleans a text column from any dashes or spaces in pandas. Give me one variation. And I'm gonna do markdown response text. And we'll see what it responds. So, okay, so we now have, wow, okay. So here's the function, import pandas SPD, import array regular expression. So clean text column, it's well documented, does some error instances to create a copy. And then here it creates a variation of this column, and then it creates a test function. Okay. Okay. And it gives me some instructions. Now what I want to do is I want to, push back. I want to give an addition, give some notes, right? So what I will do is I will create a new response variable. Oops, let's make sure that we have correct vocabulary. So send message, right? And I will say update that function to also remove any particular numbers or symbols. And I'm gonna do response.text. So again, it will take a minute or two. Okay, so as we can see here, it responded back, and then I think it should give some context here. Key improvements and explanations in this version. The function now accepts an optional cares to remove parameter. Error handling. So the updated version goes through, etc., right? And as you can see here, it still remained in context, right? Like it was able to take back what it was able to answer in the previous chat and then update it for the second prompt. And this wraps up the helper functions in the Gemini API. This is not everything. There, again, I mentioned tool use. So, for example, the ability to do Google search or the ability to do code execution, I think are really great applications here. And this makes really Gemini a very, very useful model. Now, what we're going to be doing now is going into the bread and butter of Gemini 2.0, which is the multimodal capabilities and the long context length. So Gemini 2.0 Pro has a 2 million context length input for inputs, sorry. And it also is able to take in images, text, audio, documents, and video. So as I mentioned earlier in the code along, I have a few files open here. So I'm going to first test it out on images, right? So I'm going to start with image understanding here with Gemini. And again, to create images, to help it interpret images and reason with images is actually relatively easy. All we need to do is load an image using the pill library, right? And then in the contents, I create a list instead of just a string, and then add the image as a second element of the list here. And that's really it. So I have this image just for context, this DeepSeek R1 image, which is essentially a screenshot from our blog on the topic that it's linked in the description below, so check it out. But essentially here we just go through what is DeepSeek R1, how do you get access to it, so on and so forth. And it's just the introduction. I'm not pasting the entire article. So with that said, let's open the image. So I'll first get started here, right? So all I need to do is, and you can replace your image here. Like I'll show you how to replace it for your own image, but you'll be able to check it out. So I'll do pill dot image dot open, right? And then all I need to do here is copy the path of this image, right? I'm going to set it in a string, right? So content / deepseek underscore r1 dot png. Important that you add this here as well if you're adding this manually. But again, if you have any image here, all you need to do is copy the path and upload it here, and it will be able to interpret the image. And all we need to do is just have a response equals client.models.generate underscore content stream, right? So here we're generating a content stream. The model is our model ID, has not changed. The contents, though, is a list, right? Where I ask it, explain this image. And then I'm giving it the image as an input file in the list here, right? And then I'm going to print out the chunk and the streams. So for chunk and response, print chunk.text, and then the end is an empty character because we don't want breaking lines between each chunk. So with that said, I'll start here and let me close this here. Okay, here's the explanation of the image. What the image shows, a screenshot of a portion of a blog post article. Excellent. The article discusses DeepSeek R1. Incredible. A new reasoning model by DeepSeek. Here's a breakdown. So on and so forth. And what's really nifty about this, again, this is in the API. It's multimodal. You don't need to do some complex retrieval augmented generation or use a specific vision model, right? Like this is the same model that we've been using to generate text for the past. And yeah, and here the snippet of like introduction overview longer about new AI is designed to inform readers. Okay, perfect. Now this is it for images, right? And then what we want to do now is jump into audio, right? And what's nice about the audio stuff is that, you can use Gemini to do speech text transcription, do like audio event recognition, like at what point in time did the speaker talk about this, for example, right? But in order to be able to help Gemini understand it using the API, we're going to use this function from the types package, so a types module, part from bytes, right? So we're going to help it interpret audio files, right? And then we're going to tell it that the type is an audio.wave file, right? So with that said, all we need to do is open here. So we're going to be using actually like an MP3 file. I'm not sure if we're going to update the WAV here, but we'll try it out. So we're going to do with open, right? And my audio file again is here. It's this section from the Data Frame podcast, which is Datacamp's podcast that me and my colleague Richie Content co-host. Highly recommend that you check out this episode. But we're going to open this file, right? It's a podcast with Mary Nova. It's just 4 minutes or so. I don't want to overstress the input context length window since we have limitations on per day and per minute and per hour inputs that you can add on the free tier. And then I am reading here the file. I'm saying it as F, right? And then I'm doing audio bytes. My object is called audio bytes, and then I'm reading this file, right? And then let's do a response. I'm going to try out the MP3 stuff here. I'm not sure if it's going to work out. So client.models.generate content stream, same thing. Model equals model ID, right? But the nuance here is I'm going to create a contents list, right? The first thing is my prompt, describe this audio. And then the types part from bytes, right? I'm going to do my data is the audio bytes file, right? So here, all I'm doing is that the contents is the prompt, and my file is, instead of just adding an image, right? I need to specify that it's I'm giving it a specific, I'm encoding it into bytes, and the data is the audio bytes file, and the MIME type is audio. I'm going to try MP3. In my solution code, I have this as WAV, but let me try to see if MP3 works here because my folder is MP3. And then for chunk in response, I'm going to print chunk.text and equals here, right? So if I go here again, what I did is generate a response, business as usual with the model, and then my contents are is the prompt as well as the audio file that is encoded here into bytes. So based off of this, I'll run this. It seems like, yeah. The discussion here is between two individuals about natural language processing and its application. Correct, particularly in the context of AI and business. They discuss how NLP involves helping computers understand and generate human language, like chatbots, content moderation, etc., etc. And yeah, it is correct. It appears to be an interview or a podcast segment, and that's also correct. It's a segment of a podcast. It's just 4-minute audio. And then, yeah, we'll make sure to link to the full episode in the description, but this is also really cool. Okay. Now, with that said, let's also go to one of the bread and butters here of Gemini 2.0, which is document understanding, right? Using PDFs and, given the context window, I think there's a lot of special applications here for Gemini 2.0, from summarizing reports, research papers, like extracting key information from the document or like answering questions based on a document. But what's really interesting is that the long context window really eliminates the need for retrieval augmented generation in many tasks. And I'll maybe explain why before I jump in. So I'll take this interlude here. If you look at how RAG looks like in practice, if we go back to the Harry Potter example of, let's assume we're giving a retrieval augmented generation enabled LLM a document the size of all of the books of the Harry Potter series, right? And you give it that document, it's all the Harry Potter books, and assume I think it's around 1.5 million tokens when I did my research on this. And what a retrieval augmented generation system will do is that it will divide the model, the document into chunks, so chunks of like 500 tokens or more, and provide the model these chunks, and the model will be able to search for content in these chunks using embeddings and semantic search. Now that means that these models will be good at fact finding. So at what point in time did Harry Potter do X or do Y, right? But when you reason over an entire document in context, right, that creates a lot of limitations here. So if you ask questions like, how did Harry Potter's personality evolve from book 1 to book 7, and what were the events that shaped his personality? I'm just creating a question here. I've never seen Harry Potter or read it.
Sue me. No, don't.
And that means that the model has limitations here when it comes to not being so strong at putting things into context. Another good example would be like an interview. If you create a podcast interview transcript here, chunk it, and then ask the model to locate the situation where the guest was able to say X, Y, Z, it will be able to find that. But if the guest says, connecting back to that thing that we discussed at the beginning of the episode and adds a nuance, right? The model will not be able to understand that nuance that was being made, right? Because of the chunking that you see here. Now, alternatively, when you have a long context window, right, what you have instead is a long document with n tokens, right, like a massive document. So here, like 1.5 million tokens in the Harry Potter book. And the model is able to interpret it all in one go in the same context, right? So in the Harry Potter example, Gemini would be able to answer questions about the motivations of the character, how the character evolves over time. It's just quite computationally expensive, right? Especially if you're using this at scale of millions and millions of tokens, right? So you can check out the pricing of Gemini below. I'll make sure to include it in the description. Luckily, we do have a pretty good free tier, and yeah, essentially, the model is not necessarily the best at getting the model necessarily, it will be expensive, but it's much better, sorry, at getting facts and reasoning right over the entire document. So what we're going to do here is similar to the audio file, we're going to load the document as binary data. We're going to wrap it up in the types from bytes, apart from bytes function, right? Similar to what we did. The only thing is that we're going to do the path of the file immediately and read it by bytes here using this object, right? But we're going to put it on MIME type equals application slash PDF, and then we'll be able to respond. And one thing here as well, I'm going to be using the Gemini 2.0 Flash model for this, simply because given the long PDF document I'm going to give it, I don't want to be waiting 5-6 minutes on a response here. So the paper that I'm going to be using is going to be the DeepSeek v3 paper, which you can find here. It's a pretty long-winded technical paper, right, on the DeepSeek v3 model, and it is a when I counted the tokens, around 60,000 tokens here. So definitely within the context length window for both Flash and Pro. So what we're going to be doing now essentially is creating first the response, right? So response equals client models.generate underscore content stream, right? And for model, as I mentioned, I'm going to be using Gemini 2.0 Flash, right? So this is the Flash model here. Again, really similar model. You don't need to worry about the slight trade-off in accuracy, but it's definitely going to be worth the latency that we get from reading such a big document in one go, right? So first thing is, what is this document about, right? And then I'm going to be using here, again, types apart from bytes, right? And yeah, the autocorrect was correct. The data is the pathlib to content deepseek underscore v3.pdf, and we're going to read the bytes, right? And the MIME type is application PDF. And then what I'm going to do is that for chunk and response, I'm going to print chunk.text, and I'm going to block it here. And then we'll see how it responds. It may take a minute or so. Okay, so this document is a technical report introducing DeepSeek v3, a large mixture of expert model. Its details include the model training process, infrastructure, performance evaluations, and limitations. Also, the researchers understand taking those and research project possible. Now, of course, I can ask the prompt to be a bit more detailed, but essentially this gives an overview, right? When I did try this on the Pro model, it did take a long time, but the response was really detailed, where it gave a detailed description of each chapter, each description as well. That will be included in the solution code, but I just wanted to, for the sake of brevity here, be able to go through the model quickly. Now, the next thing I want to do here is analyze a video with Gemini. So we're going to upload a video to the Gemini servers and then analyze it and prompt about it and reason about it. With that, let's get started. So the process to upload a video is a bit more complex than that of, uploading a PDF file or a MP3, but it's still going to be relatively easy for us to go through it. Now, what we need to do is use the client.files.upload function provided by the API to be able to upload the video. And then we're going to load the video with a prompt into our model. So I've already imported the time package, as you saw above. Sorry for the scroll here, it's a bit annoying. But I already imported the time package here. So I'm going to be using the time package to time a few operations just to make sure that we're not letting the model run into errors while importing video content. So with that, let's first define this new function called upload video, which takes as input the video file name and essentially kind of the path that the file is on, right? we're gonna instantiate this video file object, right, by using the client.files.upload function. So the file is called my video file name, so that's the file path, right? And essentially what this function does is that uploads the video file to Gemini. Now I'm gonna set these this while statement here. While the video file state equals to processing, so while the video is still processing and still being uploaded, I'm gonna print a message that says waiting for video to be processed. And then I'm gonna sleep for 10 seconds. So here I'm using the time function. And then I'm gonna attempt to get the video file back. So client.files.get video file, and that's not ID here, it's name. And one thing I'm gonna just, because I ran into error when I didn't do this, I need to set my name variable to be explicit here. Name equals video file dot name. And then, this will still run while the video state file is equal to processing. So I'll wait till the video file is completely processed. Now, one thing, if video file dot state equals to failed, that's what's really important, we're gonna raise value error to video file dot state, right? We're just gonna raise the error here and then print otherwise. So video processing complete plus, let me put a space here, the video file URL on Google Gemini, which is .URI attribute, and we're just going to return the video file object here. So what we did here is we uploaded the video file from the path to Gemini. While the video is still processing, we just add this message that says waiting for video to be processed. If the video has failed, we get an error. Otherwise, we say the video has been complete. Here's the URL on Google Gemini. So the video that I'm going to be using is a video on ChatGPT tasks that we uploaded to our YouTube channel. It's a relatively short video, like 10 minutes long. And, I don't want to overstress the content length window. So we can, use a short video for this time. So what I'm going to be doing is ChatGPT tasks _ video, right? And I'm going to upload the video. And again, all I need to do is just give it the path. So the path is this one, right? I'm going to cancel here, right? And then I should get here a few messages. So the video is being processed. Let's see what happens. Most likely it's going to go back to it after the 10 seconds is gone. Okay, the video is still being processed. Okay, the video processing is complete and the video has been uploaded. You can check it out here on that link, right? So now all we need to do is reason with the video about Gemini. Now, given a lot of the tasks that I'm about to be doing moving forward are going to be really focused on kind of long context length tasks similar to the PDF document, I'm going to change my model ID to the Gemini 2.0 Flash model, because that one is faster, even though it gives you maybe less quality results, but still useful for our use case here, right? So what I'm going to do is I'm going to set response equals client.models.generate content. So the model is my updated model ID, which I'm now using Gemini 2.0 Flash, right? And the contents will be, so we've created the video has been uploaded to Gemini, right? So essentially it is the file object here, ChatGPT tasks video, right? And then I'm going to ask it, what is the content of this video? And then based on this, I will print in Markdown my response.text. So let's see what it says. Okay. This video is about a new OpenAI release called ChatGPT Tasks. The speaker discusses that this new tool allows ChatGPT to go beyond chatting and to create tasks for users such as reminders, daily newsletters, stock updates. That is completely perfectly correct. The speaker describes it as similar to Google Tasks, but with a brain. That is also correct. Proceeds to show what the mentioned blog post looks like. That is also correct. Whereas mentioned the tool is in beta and that only be released to Plus, Pro, and Team Plan users. It's supported on ChatGPT Web, iOS. Yeah, perfect explanation of the video, and you can get it here, right? So far we've been looking a lot of kind of different pieces of the puzzle, right? Here's how you generate audio, how you process audio. Here's how you reason with a PDF. Here's how you reason with a URL, with a video, so on and so forth. But what I want to do now is put it all together into a multimodal application, right? Using Gemini, with the objective of something that helps me solve a daily workflow that I have, right? So I create YouTube content. A big part of creating YouTube is not just creating the coding content and going on camera and coding, right? But it's actually doing stuff like trying to get ideas for what videos I should create, or if I have a video, what should be an SEO appropriate description for the video and title for the video. So these actually take a lot of brain space and time, right? And I want to see if I can automate them with Gemini. So what I had in mind was creating like a Gradio app, right? Where essentially I get to choose two options, a PDF processor or a video processor, right? If I choose PDF processor, I get an interface that looks like this: upload a PDF, I upload it, and I have three buttons: generate YouTube script, summarize this document, give me video ideas, right? And then I have, if I press on video processor, I go on upload a video, I give it a URL of a YouTube video, and then what it does is that generate chapters for me and generate titles and descriptions, right? I'm going to use only the YouTube example today, but of course for my workflows, what I can do is give it any link to a video, right? And then, for example, from Google Drive or something along those lines, and then it will be able to also create content for video that's create chapters and titles and descriptions for content that's not yet on YouTube, right? So that's something to think about. And what we're going to do to put it all together, right? One, we're going to define the logic for the video processing function, right? Then we're going to define the logic for the PDF processing function, and then we're going to put it all together in a Gradio web app, right? So step one, let's jump into it, which is the video processor function. So step one has two steps, right? We want to upload the video, right? Similar to what we saw previously, right? And then the second thing that we want to do is process the video by Gemini. Now, the upload video function will be really close to this one with a few really minor updates, right? So actually can be relatively the same here. Okay, so let's actually go through it again just so we can explain the logic step by step, because it's going to be integral to the second function as well. So we're going to do upload video, and instead of video file name, we're going to call it video path, just to make it more clear, right? And then what we're going to do is we're going to create a video file object, right? So client.files.upload file equals video file path, indeed, right? So here what we do, I'm going to comment it out, upload the file to Gemini. And then we're going to understand if the video is still processing. So while the video file.state equals to processing, we're going to print waiting for the video to be processed. Ooh, got a lot of autocomplete here. We're going to sleep for 10 seconds, and then video file will be client.files.get name equals video file name. Okay, so here we're going to refresh the file status and see what we get. And then if the video file.state equals failed, right, we're going to raise a value error that says video processing failed. So these are some of the nuances that I'm adding here, right? And then what I'm going to do is, again, same as before, video processing.complete plus the video file URI. So let me just put this in here. Okay, and then we're going to return the video file, right? So this will help us process the video. Again, really similar to the function below. I just made sure that I updated the value error and cleaned up a bit the output. Now, the second step is that we're going to create a function that processes YouTube links. So what they need to do is first we extract the video metadata using the YTDLP function. And don't worry, if you're not well aware of the YTDLP package. One, you have generative AI tools that can help you create the code, the boilerplate, while you figure out the documentation, right? But secondly, what's more important is that you have a good idea of the system design that we're doing rather than the exact syntax. So we're going to extract the video metadata using YTDLP. Then we're going to download the video using wget. We're going to upload the video using the upload file function that we just created to Gemini. And then we're going to generate insights based on two types of prompts, right? So the prompts will already be there. You can see them here, and then we can check it out. So what I'm going to do is I'm going to do a function called process YouTube, and it takes as input two arguments, the YouTube URL and the prompt choice. So first thing I'm going to do is I'm going to define some options related to the YTDLP package that lets me extract exactly what type of metadata I want to extract from the YouTube videos. So I'm going to call this YTDL opts, right? And I'm going to set this to format is best. So this lets me get the best possible quality of video available. I'm going to set this quiet is true. Let me just delete these. All right, so quiet is true, and this suppresses any unnecessary output. And I'm going to do skip download equals true. I don't want to download the video from here, from YDL ops. I want to download the information from the video, so I can download it using wget. And then what I'm going to do is I'm going to say with my YTDLP YouTube download function, right? And I'm going to give it as input the dictionary we just defined here, right? And I'm going to name this as YDL. I'm going to extract an info dictionary, right? That says YDL.extract info. Okay. Indeed, the YouTube URL plus download equals false. That's all I need from here, right? And then what I'm going to do is I'm going to define my output file name. So the output file name, what should the video be called on my local machine, right? It's going to be called, I'm going to get it from the info dictionary, right? And if you want to see what this info dictionary looks like, just run this piece of code, not in the function, right? And give it any random YouTube URL. And you'll get a dictionary full of metadata, length, number of captions, so on and so forth, etc. And one of them is full title, right? And then what I'm going to do, though, make sure it's called an MP4 file so we can interpret it as an MP4. And then I'm going to print the output that says downloading video to output file name, right? As you can see here. Now, one thing as well, I want to get the direct URL from the YDL.extract info. It's just because when you use wget, sometimes you can have different types of formatting for your URL. So I'll get the URL directly from the info_dict object, right? So direct URL equals info.dict, right? And I'm going to use here URL, and I'm going to format it as such. So formats 0. And again, you don't need to necessarily be fully aware of how the YTDLP module operates. It's just we're going through some boilerplate code here, right? And then I'm gonna print as well direct video URL extracted. And I'm going to call this direct URL here. Okay. Now, what I'm going to do is I'm going to download the video now using wget. So I'm going to start a message that says downloading video. Let's just make this easier here. Downloading video to output name. Right. And then what I'll do is I'm going to do wget.download direct URL, and I'm going to save it to the output file name. Right. And then once it's done, I'm going to print another function that says downloaded video to output file name. And then now that I have the video, right, I have the video on my local machine, right? So what I can do is I can use this function, right? I'm going to create a YouTube video object. And what this does, I'm going to upload my video, right? And what's the path of the video? It's output file name. And then it's uploaded to Gemini. So this step, what it does, it uploads to Gemini. Once it's uploaded to Gemini, I don't really need the video anymore on my machine, right? So Colab does not give you a large amount of space, right? So what I'll do is I'll just use the OS package to remove the output file name. This, what it does, it deletes the file. And then what I want to do is I want to create my prompts, right? So I have two prompt options. The first one, I'm going to set them in a dictionary, right? So the first one is generate chapters. And I'm going to just copy paste this here from my solution code just to make it easy. So organize all the scenes from this video into chapters and chapter markers. Output your response as bullet points, where each bullet is a chapter marker and the title of the chapter. And then I'm going to name my second prompt option, generate title and description. Provide one short YouTube title and description for this video that is both accurate, engaging, and SEO friendly. So we have two options, generate chapters or generate title and description, right? And then what I'm going to do, I'm going to create a prompt text object, right? Which from my options, right, the default will be .get prompt choice. So it's the prompt choice here that we set, right? And otherwise it will be generate title and description as the default. And then the output will be a response. So we're going to set a response equals client models generate content. So same, the model is the model ID, which is now the Flash model. The contents are the YouTube video, right? And the file that we uploaded, right? And the prompt is the prompt text. So the autocorrect understood what we're trying to do here. It's the prompt text, right? Now, one thing I want to do is I'm going to make my output 200 characters long, just again, because this will be relatively complex to do, especially with the Pro model. Luckily, we're going to be using the Flash model, but the max output code tokens, I'm going to set this as 200, right? And then I will do return response text. I'm not going to set it in Markdown because we're going to be using Gradio here, right? So let's go back logic by logic. What we did step by step to go through the logic. We defined these YDL YouTube downloader parameters, right? We extracted an information about our YouTube video. From the information we got the full title and the URL and created the output file name. We started downloading the video using wget, using the direct URL and and saved it into the output file name that we created. Then we uploaded the YouTube video to Gemini and instantiated the YouTube video object that works with Gemini. We removed the video from a local machine because now it's on Gemini. We created different types of prompts, and then now we're just creating responses based on the type of prompt that we have, right? So we can test out this function here. I have these parameters, right? I have this YouTube video, which is essentially a Datacamp video on a topic of your, on a group by SQL, right? And with that, what we just need to do is add the YouTube URL. We have it. The prompt choice is generate chapters. Oops, let me fix this, right? So, and I have here this slider where you can choose either generate chapters or generate title descriptions. So I'm gonna generate some chapters and see if it works. And what you should see here, ooh, it has no attribute YouTube DL. Where did I go wrong? Let's see. Oh, I put a capital T. It should be not capitalized. So with that said, let's try it right now. And if it's working, okay, we should see a video appear here, then removed. Ooh, infodic is not defined. Oh, I made a typo here. Haha. Let's see again. It's part of the game, part of the game. Okay, let's see. Okay, download the video is here. Downloading the video has been downloaded. Waiting for the video to be processed, so it's being uploaded now by Gemini. The video is still here. So it's in the process YouTube function. So it is, where's my error? Line 15. Wait. So print video processing complete plus video file dot URI. I think this is from here. Oh, I should have set this like this. Why is this? Okay, let's see if it works now. Because this is essentially the same that was set. Okay. Now, let's see how this goes. Okay, so here are your chapter markers. From 0 to 1, grouping data, group by single fields, error handling, group by multiple fields, group by with order by, so on and so forth. Okay, it works perfectly. I'm gonna delete this video here because we have a duplicate video, since we ran the download twice. Now I'm gonna try out the second functionality, which is generate title and description, and I'm gonna do my prompt choice here, and then I'm gonna process the YouTube. The YouTube is gonna download again. The video is downloaded. It's downloaded, as you can see here. Okay, so title, grouping data with SQL, intermediate tips and tricks, description, learn how to use group by terms, blah, 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 gave keywords, yada, yada. So perfectly works. Now, step 2 of here defining our web app is defining the logic of the PDF processing function, right? So as I mentioned, I don't want to just do the video task, but I also want to be able to upload a PDF, generate a YouTube script from it, summarize it, get video ideas from it. Especially if, I'm uploading a paper and I want to get ideas based on this paper. So all we need to do is create a PDF function that takes in as input the path or the file, depending on whether we were using Gradio or we're using just a traditional code cell. And then based on the path, we open the file as bytes, right? And based on the prompts that we have, return a response based on the prompt that we've defined. So with that, let's get started. So what I'm going to create is I'm going to create a function called define process PDF, and it's going to take as input the PDF file as well as the prompt choice. And then what we're going to first do, right? I ran into errors while doing this because I want to test this out both in code and on Gradio. And when you use Gradio, you upload an object. So I want to be able to, depending on whether I'm uploading an object or just giving the function a path, be able to process the file nevertheless. So I'm going to use the if_is_instance function. And if my PDF file is a dictionary, right? And it has a name attribute in the PDF file, okay? Then my file path is PDF file name, right? And this is for Gradio. Here I'm taking in the file path from the name key that it has. Now, if my PDF file is a string, right? Then the file path is the PDF file, right? And then else, thank you, autocorrect, we raise a value error that says invalid file format, right? So with that said, now we have the file path instantiated depending on whether it's an object or a dictionary, or whether it's an object or a path, right? So what we're going to do now, we're going to read the file. So we're going to open the file depending on the file path that we have, right? We're going to put this here, RB, and as file as F, and we're going to read the PDF into bytes. So f.read. So similar to what we did earlier, we're just like standardizing it in a function. Then what we're going to do, we're going to define our prompt options as well, similar to what we did before in the YouTube example with the dictionary, right? And then what I'm going to do, I'm going to paste them here just from my solution code just to make it a bit easier, right? It's going to be YouTube script. So create an engaging YouTube script based on this document. Then summarize the document, summarize this document for me. Then video ideas. What are your YouTube video ideas? What are other YouTube video ideas, sorry, I can pursue based off of this document, right? And then we're going to return a response based off of these options. So I'm going to define my prompt text function, which is object where based on these options, right? I either get the prompt choice or YouTube script by default. Right? And then all we need to do is generate the response. So what the response here will be doing, right? We're going to create it in streaming mode. Client models dot generate content stream. And then my model is my model ID, which again is the Flash 2.0 model at this point, because we want to save on computational costs and latency for this use case. And then what we're going to do is the content will be from the types module. We're going to do from bytes. The data is the PDF bytes file object that we created here, right? And most importantly, the MIME type here equals application PDF. And now, what is the second aspect of my prompt, of my model response, is the prompt text. So here, this is the prompt text that's being chosen is one of these options that I choose. And then what we're going to do, since we've been doing it in streaming mode, we're going to collect the full response, right? And then what we're going to do is for chunk and response, I'm going to do plus equal chunk dot text. So here I'm just adding the different chunks to the full response, and then we return the full response at once. Yeah, in all honesty, we could have just created generate content and just did return full response here, right? But I wanted to show as well different modes of operation and how you can interact with the model. Now, with that said, what I'm going to do here, I have the PDF file, DeepSeek v3, the same one that's in that we've already used to process, right? And then based off of this PDF file, create a YouTube script, summarize a document, or give me video ideas. So let's see if this runs or if we have any errors. Okay. Um, so let's see. Okay. Here we can see a YouTube script. So as you can see, thanks for watching. I'll see you in the next video, so on and so forth, right? And it has timestamps as well. And it gives me as well visuals to add. That's actually pretty interesting. Now, I'm going to try here video ideas based off of this updated prompt as well. Okay, I can help you brainstorm some YouTube ideas for the user breakdown, potential DeepSeek 3, a deep dive into the architecture, explaining the multi-head latent attention mechanism and Speak OE architectures, auxiliary loss free load balancing, the DeepSeek v3 innovation, so on and so forth. And yeah, it gives me a lot of different ideas, which is great to see. Now, what I want to do is put it all together in a Gradio app. And I left the code here intentionally because the purpose of this video is not to teach you how to use Gradio. It's to teach you how to use different tools together to build like simple web apps, right? I'll explain the code line by line. But essentially, if I go back to this design that I created here, right? I want a simple interface where I'm able to upload a PDF if I select PDF processor and upload a video if I create video processor, right? So what I'm gonna do here is I'm gonna create using this with statement, I'm gonna create a demo object using the Gradio blocks function, right? I'm gonna add a title and description to my app. This is always present on the app, and then I'm gonna create two tabs that I can select between both. The first tab is called PDF processing, and here the markdown title says upload a PDF file and select a prompt. We're going to create a file input object called PDF input, right? So this allows me to upload a PDF, right? And then there's a prompt selector, which lets me select between the choices YouTube scripts, summarize documents, and video ideas. And again, they need to be the same exact thing as what you see here in the prompt options, right? And then based off of the choices, right? We select the default value here, which is YouTube script. The output, right, will be in a text box in a response, right? The button will let us trigger the response. But on the click, what will happen is that the process PDF function will trigger, and the inputs to the function will be the PDF and the PDF prompt, right? And the outputs will go to the PDF output. So that is essentially the logic that we're creating here. Same thing on the YouTube processing tab. We have the markdown title. The YouTube URL input gets the text box treatment, right? It's just a text box where we upload the YouTube video URL. Then we have two choices. Again, same exact match for the YouTube prompt here, and we have the default selected option. The output will be responded in a text box. The button will let us click on process YouTube video. And then upon the click of the button, the function process video will run, and the inputs that it will take will be the URL that we inputted here, as well as the prompt that we put here, and the output will go to the YouTube output box, right? And then I'm gonna put here demo.q to, in case there's any long-running functions to improve the responsiveness, and then I'm gonna launch the Gradio app. So once I launch this, I'm hoping that I get a correct application. So I'm gonna open this here just to make it clearer for everyone. It's gonna be live shortly. And again, here we have Gemini API code along application, right? Upload your PDF file or YouTube processing, right? So I'm going to take in a YouTube link, for example, and test it out. So I'm going to paste the same YouTube URL. I'm going to generate the chapters. It may take a while, especially using Gradio, because we're using Gradio servers here. But let's see how it performs. Wonderful. So now we have a YouTube URL that gives us a response on, here's the chapter markers for the video. They work perfectly. And if I want to generate a title and a description, I can also do that. So if I press on process YouTube video, let's see how it performs. Hopefully we're not hitting the limit of how many queries I can run on a given minute. And beautiful. I have now a title and a description, SQL grouping, easily summarize and analyze your data, learn the power of SQL group by clauses, blah, 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 etc., etc. Now I have a strong starting point for editing the title and the description. Now, same thing on the PDF file. All I need to do is drag a file or upload a PDF here directly. So if I go on DeepSeek v3, I have it here. I'm going to ask it summarize this document for me. I'm going to give it a few seconds just to make sure that we're not running into the limits. Wonderful. So now here's a summary of the document, so on and so forth. 671 billion parameter, that is correct. 37 billion parameter per activated token, so on and so forth. And yeah, we can give it a YouTube script, give it YouTube ideas. We've already run these before, but it's a great web application for a multimodal application that was all built using Gradio and Gemini. No retrieval augmented generation, no other types of tools, no databases, all inputted, all multimodal, all using the same model. And with that said, I think we can wrap up today's session. I do want to mention, on the software that we just created, it has a lot of limitations, right? One, it's resource intensive. Each time you need to run Gemini, you're using servers here. If you're using an extremely big video or extremely big PDF, it will take a while, right? It is brittle. It can break, right? I'm fairly certain if we test it on different types of videos, maybe file names that have weird file names, PDF files that are too big or have images, maybe it could be potentially break here, and we would need to find some debugging recourse. It's also slow. If you notice, we don't do any caching. When I ran the SQL video, I downloaded it twice, right, on the two different prompts. So if I want to make this production ready, I would create some caching strategies here to make sure that any video that is already there is checked upon before we download it again. Make sure it's not as resource intensive. Yeah, that's essentially some of the limitations with this software that we created. But that said, we just use Gemini to be able to build a multimodal application that helps any YouTuber on their daily workflows absolutely for free using the generous free tier that they have, and we're able to build a completely end-to-end multimodal system, right? So it really shows you about the potential for large context length windows and multimodality and creating simple applications that actually scale. And I'm very excited about that. Now, with that said, I'll leave you with this code along. Do check out the links in the description. Do check out our Datacamp courses on LangChain, Retrieval Augmented Generation, as well as the OpenAI API, as well as our AI engineering career skill track, which I think would be very relevant here for anyone looking at this video. And with that said, I'll bid you farewell and see you on the next one.